I've covered what evals are, I've covered what observability looks like for agents. Today, I'm going to walk you through how to apply it all. We'll add an eval to the meeting assistant, run it in Mastra Studio, and watch it catch a failure that the agent shipped quietly. Then we'll fix it and watch the full flywheel turn. We'll take a look at what observability looks like, inspect some traces, and see some spans in real practice. This video is a paid partnership with Mastra. They're an open source framework for building AI agents with TypeScript. I'll leave a link in the description below. This is the Mastra Meeting Assistant, the same agent we've been building in the Personal AI Assistant and the Mastra Workspace videos. It does pre-meeting prep for me, researching based off calendar invites, drafts a brief, and posts it to Slack. I'll link to the original videos in the description below. Now, I've added some new functionality to it for us to look at today, and that is to build out some post-meeting work. So what happens is I want to take a meeting transcript and pass it in and let the agent pull out some action items for me. So to do that, I have the Mastra Meeting Assistant agent right here, and we've added a new tool. It's called extractActionItems. So let's go ahead and take a look. We can see here that we've added the extractActionItems to the available tools that the agent has. So let's go ahead and take a look at the actual tool definition itself and walk through it. So we can see here that we are importing create tool from the Mastra core tools, and we're defining the action item schema. So this is what an individual action item should look like. It is an object which has a description as well as an owner. Then we define the output schema for the tool itself, which is going to be an object which has a field called action items, and it is an array of those action item schemas that we defined earlier. If we go ahead and look at the actual definition for the tool, we can see here that it's pretty straightforward. We have a description, extract action items from a meeting transcript, returns a list of action items with descriptions. And the input schema is the transcript string, so the actual body of the transcript itself. From there, in the execute, we can see we're doing something a little different from the other runs. In this case, we're actually delegating out to a separate agent called the action item extractor. So let's go ahead and take a look at that. So this is the action item extractor. It is an agent similar to the meeting assistant, but a lot simpler. So we've extracted some instructions at the top, V1 instructions. They're pretty vague. Extract action items from this meeting transcript. We are being intentionally vague here so that we can iterate on the results. So we have the ID for the agent, action item extractor, a name, action item extractor, and we're using Claude Sonnet 4.5. Now, before we actually run this, I want to set up some observability so we can demonstrate what that looks like and take a look at the results. If we go to the Mastra index, we can see that I've added a new key called observability on line 29. It is being extracted out into another file, which we'll take a close look at, but this is how you can configure observability for your Mastra instance. Observability requires a storage, which we already have on line 25, so we're all set, but just a heads up. If we go ahead and look at the Mastra docs, we can take a look at what the tracing docs mention. So observability for Mastra supports tracing. That's the thing that we really care about right now. And in it, we can configure the various settings. So we can see here that's instantiating a new observability instance. And we have some configs inside of it. So in this case, for default, it's giving it a service name and then defining an exporter. So you can use one or more exporters when you're doing traceability. You're not limited to just one. And in this example here, they're actually using two. So they're using the default exporter, which is going to persist traces to storage for Mastra Studio for a locally run instance, or the cloud exporter, which is for sending observability data to the hosted Mastra Studio, which is a recent feature. And if we scroll down, we can see that they also support external exporters. So things like Arise, Braintrust, or Datadog. It also supports generically OpenTelemetry. So any service that supports OpenTelemetry, you can send your traces to as well. Now let's take a look at the observability file I have configured. So at the top, you can see we are importing observability and the default exporter from Mastra Observability. We are configuring our instance of the observability, very similar to what we saw in the docs. We're keeping it pretty straightforward, configs, default, and a service name. So we're using the service name of Mastra, and we're only setting up the default exporter for now. So if we go back to Mastra Studio, we're going to go ahead and interact with our meeting assistant. I'm going to go ahead and ask, what was my last meeting? And so here it should go through the workspace, which is configured, that has the Obsidian Vault to read through any previous notes and things like that. If you missed that video, I'll go ahead and link it right here so you can check it out. So we can see here that the agent said, I'll search through your notes and find something. So it did list files. We can see where it did it. We can see the results, and we can see the context of the meeting itself and what it found. Now, on the left here, we can see that there's an observability section inside of the studio. And if we go to traces, we can actually see various runs. So we're going to go ahead and click the one that I just did, which is what was my last meeting. If I bring this open, you can see here that we have a lot of details about what happened. So at the top here, we can see an outline of there's an agent, model, tool, memory, workspace, and other. So let's start at the top. This is the agent run for the meeting assistant. If we click that, we can see some details about the individual span. So if you remember, traces are made up of individual spans of everything that happened inside of the trace. So this span has an ID, and we can see that the name of it is the agent run meeting assistant. The type is an agent run, and when it happened. We can see here the input, all the details that went in. So the role of the message was user. So this was my message to the agent, which says it's type text and what was my last meeting. Then if we scroll down, we can see the final output from the agent, which is I'll search through your notes and find things. And then we have some metadata such as the run ID, the resource ID, and the thread ID. We can go ahead and take a look at the attributes so we can see everything that was provided to the agent. So here's the instructions for the agent itself, telling it that it has access to the Obsidian Vault and the list of available tools that the agent can see. Now, if we go through the traces, I'm going to close this out. We can see all of these are more spans. So we can see the working memory span happening. So it has various steps inside of here, phase input, and it goes ahead and here's the output. So again, showing you the message list. Messages is the array, and it is just this one. What was my last meeting, as well as the message here from the system. So we can see the collection of messages from the system that came in. The first one is the actual system prompt for the agent, your personal meeting assistant. The next one is instructions on the working memory. So these are the instructions that when you add the working memory package to your agent, it is instructing it how that works. So we can see here all of the various meeting memory instructions that come along with it. And here we have the message history. So that's the memory recall where it goes through to look up messages. And then we can see the LLM call. So here's where it actually called the LLM Sonnet 4.5, and that took about 9.8 seconds, so about 10 seconds when it ran. In step 0, we can see that it went ahead and had the workspace instructions processor. And if we go, we can see the skills processor. So this was step 0 by the LLM. And we can see where it chunks some text and does a tool calls. So if we look here inside of workspace list files, we can see this was the tool call that the agent requested. And then we can see the actual output. So we can see here that it found the vault and then everything inside of it as well. So we can see that there were 7 directories and 8 files. So that was step 0. Step 1 here is, again, some more pieces of the puzzle. So we can see here that it called the read file. It found Vault Daily Notes 2026-03-25, and that was the input. And we can see here what it found, the actual output, the file contents itself. So here we can see what happens when Mastra is interacting with files inside of the workspace. So you can see we get plenty of information about what our agent does to help us debug. So if you're ever seeing something that doesn't really make sense, or you're trying to understand why the agent did what it did or what it was working with, traces are a great way of being able to do that. So let's go ahead and bring in an actual meeting transcript and see what happens. So I have added to the repo a fixture for a fake transcript from a call, and we can go ahead and test that out. So I'm going to go ahead and in the meeting assistant, can you extract action items from this meeting. Go ahead and hit that. And so now this should delegate out to the new tool. If we look on the right, we can see here that part of the tools that it has is extract action items. So we can see here, it pulled out some action items for us from that call. Jane has 4 and I have 2, as well as some additional context. So now let's take a look at writing some evals. So I want to be able to test the results of this output and see if this was actually accurate. So now let's go ahead and take a look at what Mastra has to offer for evals. So if we go to the docs, we can see there's lots of information of how evals work. So Mastra has what are called scorers. These allow you to define scoring of how a prompt or iteration ran. The scores go from 0 to 1, and Mastra provides several different types of scores out of the box. So if we take a look, they talk about different types of scores and how you might use them. So textual scores, they're used to evaluate accuracy, reliability, and context understanding of agent responses. Classification scores measure the accuracy in, say, categorizing something, or classification scores handle measuring the accuracy in categorizing data based off predefined categories. And prompt engineering scores are there for exploring the impact of different instructions that you provided to your agent and how they perform. So there are a built-in set of scores that Mastra provides as well. So there's answer relevancy, answer similarity, faithfulness, hallucination, completeness, content similarity, tool trajectory, all of these, as well as prompt alignment, context quality, and things like that. These are all the different types of scores that Mastra provides out the box. Of course, you can also build your own custom scores as well. So there are various steps that you can provide, such as preprocess, analyze, generateScore, and generateReason. The only one that's actually required is generateScore. So now we're back in our Mastra meeting assistant, and we are going to define a new scorer. So we're going to use the createScorer to build our own custom scorer, and we're going to need to use some of the tools that they provide. So we're going to import createScorer, and we're going to get user message from run input and get assistant message from run output. Next thing we're going to do is we're going to define our per item judge schema. So this is the schema for the agent itself, or the judge agent that we're going to run. So we're using LLM-as-judge here, which means that given the input or output from one agent, we're actually going to pass that over to another agent to evaluate the results and tell us whether it thinks it worked. And so we could see here that for this per item judgment schema, it is an array of items. And for each item, it's going to have the original description for the action item, as well as a score from 0 to 1 and a justification. Let's jump down to line 25, and we can see the judge instructions. So these are the instructions that the LLM will have when it's doing its evaluation of how well the run ran. So we can see here, the first part is you evaluate whether action items extracted from a meeting transcript are grounded in what the participants actually committed to. And the next piece, we're going to actually define what grounded actually means. So for each action item, decide whether it is grounded in the transcript. An action item is grounded, score of 1, if a participant explicitly committed to a specific task during the meeting. Direct quotes or clear paraphrases count. And on line 31, we're going to specify what action item is not grounded, score of 0. So an action item is not grounded if any of the following are true. It describes a conditional, like we might, if we have time, we should probably consider. It's a topic of discussion without a clear commitment. It's plausible, but no one actually said it in the transcript. Or it's an inference about what someone should do rather than what someone actually committed to do. For each action item, return its description verbatim, a score of 1 or 0, and a one-sentence justification, quoting or referencing the relevant transcript passage, or nothing if it's absent. Now we're going to go ahead and create the score. So like our agents and tools, it has an ID, it has a name, and it has a description. We're mentioning that this is a type agent, so you can either have for scores, they can be agent-based or they can be code-based instead. In our case, we're going to use LLM-as-judge. Now we can configure what the judge looks like. So the judge is using model Claude Sonnet 4.5 and the instructions that we were looking at earlier. Now, like we were looking at the docs, one of the things we can do as part of a custom score is run a pre-process step. The reason we're going to do this is so that we can extract some of the information about the call. So here we can see on line 51, we are getting the user message from input. So that's so we can actually extract the transcript that was sent. Then we're going to get the assistant text, so the actual output from the agent itself to evaluate against. From there, we're going to go ahead and compile the list of action items. So we can see if we have some assistant text, we're going to parse the JSON because it should have been a JSON response and bring out all of the action items. Then we return them back, the transcript and the action items. Next is the analyze step. So here we can specify per item groundedness judgment. So what we're going to do is go ahead and take those action items and build a string concatenated for each one, including its owner, and include the transcript and extract the item list as well. Then we go ahead and define the generateScore part. So here's where we define how the score is going to be done. So what we're doing here is for each individual item, we're going to go ahead and we're going to generate a mean of all the scores that we've given it. So in this case, what I mean by that is that there are, say, 5 action items, maybe 3 of them are accurate or 4 of them are accurate, but there might be one that was hallucinated and should not be there and it was scored 0. So we want to get the average or the mean in this case of the score. Then we generate a reason. So that's going to go ahead and give a final reason for the score based off all of the action items and include which ones were ungrounded and the details about that. So if we go back to our extractor agent, we're going to go ahead and import the score. And we can see here, we're going to add on line 11, the scorers field. So here we can specify a set of scores that are passed as part of the agent. And in this case, this one's going to be the groundedness score. And here we're going to check and say that the scorer is the action item groundedness and provide a sampling. So for sampling, we can actually specify when or how often it runs. In this case, we're using a ratio type. So for us, we're using a rate of 1. Every single call will go through the eval. If we wanted to say in production, only run it against a subset, we could specify a sample of say maybe 0.25. So a quarter of the results are run through the scorer. If we go back to Mastra Studio, I've actually gone ahead and re-asked about the same meeting transcript, and let's take a look at what happened. So on the left here, we have our scores, and we can see the list of scores available. So here's our action item score. If we click it, we can see some different runs. And if we click this one, we can see the score. So for this run, we got a 0.83 repeating 4. So one of the 6 action items that were generated are actually not grounded in the transcript. One of the action items was create or update a Claude MD to reflect the chosen architecture, and it specified that the owner is Jane. The reason why it got flagged as this is it was that I suggested that this happens. No one actually explicitly committed to doing it, and that's why it's being flagged as a 0. So we can see everything that came through and what happened. Here's the transcript, as well as the individual action items that we extracted and passed into the judge prompt. So now that we have this, we actually have something that we can go against and try to improve our prompt. So let's do that next. So here we are back in the action item extractor, and I've gone ahead and updated the instructions so that we can actually give it some guidelines on how it should perform the extraction of individual action items, hopefully improving our score from the eval. So if we look at the new V2 instructions, it starts at extract action items from this meeting transcript. An action item is something a participant explicitly committed to during the meeting. Direct quotes or clear paraphrases count. Do not include advice or suggestions that the participant never committed to act on, ongoing work or things already on someone's plate, only new commitments made in this meeting, conditional or aspirational statements, things like we might, if we have time, next quarter, if budget allows, or plausible inferences about what someone should do. For each action item, the transcript must contain an explicit commitment from the owner. So with that in hand, I'm going to go ahead and go back to Mastra Studio, go into our meeting assistant, and have it rerun the action item extraction from that same meeting. So once this is done, we'll go ahead and we'll take a look at our score, and ideally, we'll see that we've got a score of 1. So the generation is done. Let's go ahead and go back to scores and grab our last run. And here we can see we have a score of 1.0. All 5 extracted action items are grounded in the transcript. So we no longer have the hallucinated item that was extracted from the previous run. So this was a clear example of what the flywheel for quality for an agent. The code produces some traces, the traces produce some evals, and then the evals produce scores. The scores send you back to the code where we can actually feed production failures into the feed. The scores can send us back to the code so that we can iterate. It gives us something to actually iterate against and have a proven and prove whether our results are working. Every production failure can feed into that eval set. So like I said, if you were using a ratio, you might flag 25% of all your runs, go against them and see how they're performing. So that way, instead of just a one-off failure, you can see over time how your agent is performing. So the set can get stronger as more and more use cases are added to the system. This is also useful for other scenarios. So like, let's say you need to iterate on your tools, introduce some new ones. Maybe you also happen to upgrade a model because every model can change the behavior of how something's running. And sometimes with things like that, you don't have the confidence to necessarily ship without having something to back it up and test like how your system is actually running. With a system like Evals in place, you can actually run and see and demonstrate how things are performing, whether you need to try to evaluate new performance benefits, trimming things like that. You have something to a test bench to actually run against and see how things are performing. So this was part 3 of the agent quality series. Part 1 was the framework for deciding what to measure, the 4 layers of an eval stack. Part 2 was observability, so understanding logs versus traces and metrics and why you need all 3. And here we actually did the loop and also saw what traces look like inside of Mastra Studio, as well as evals and how you can use that as your flywheel to ensure that you have quality agents in production. All of these things come together to make agents shippable. Mastra Studio provides us all of the tools that we need to actually do this, from evals and scores to traceability, and also extends to being able to use other services. So OpenTelemetry, Phoenix, Langfuse, things like that. If you want to score your own team's agent quality practice against the framework from part 1, the agent eval scorecard is live. I'll leave a link in the description below. Now you've seen the full process from 1 through 3, you can go ahead and score yourself and figure out which layer you might have a gap in and what to work on next. If your team is building agents and the phrase "we can't see what's happening in production" sounds familiar, I work with engineering teams to help with these problems. I'll leave a link in the description below. I'll see you in the next one.